So thank you so much once again to all the uh, you can say organizers and Professor Adil. Some slides are repeated here, so I will skip it here. You can see here now we are moving toward IoT. The data is actually required for artificial intelligence to take the decision and predict the future. So these IoT devices are actually helping us to gather those data, which will be available to the AI tool further. So here is the agenda that we will discuss. Here is my profile. It's a bit updated, and you can see here I was recently listed among the top 2% scientists of the world. And here is the Kazakhstan University. And now I will aid the Kaznaro University as well to be a collaborator with them as well. So we have, after getting the ISS co-chair, let me tell you, Dr. Adel, that we are more focusing on Muslim countries as well. Earlier, we were more focusing on West, Europe, United States, and so on. But after getting the chair, we are more focusing on the Muslim world. And thank you for that, for providing me this opportunity to connect with. Thank you. Thank you. Yeah, actually, you guided us. Yeah, toward that side. Thank you. So here is the traditional agriculture practices. You can see all the workers, they are tired and they are unable to work here. Similarly, here you can see a vestige of water. You don't know, there's no control that how much water you will provide. Similarly, here you can see the pesticide and the fertilizer, and any increase or decrease may affect the life of these crops. And here are the challenges of traditional agriculture farming. And if we have a look, there are three things which disturb or causes damages the most. The sun, which is temperature, then the wind, and then the rain. And for example, if we control all these things or take the necessary measure or precautionary measures to get into that, then we can have a very successful crop production over there. This is the new concept which can be more helpful for IoT. You will not need more IoT devices, and that is the virtual farming. It will need less space, it will need, but it's only for the small plants, remember. It's not for the big plant. So especially for the vegetable, if you see the vegetable plants are shorter and smaller, so you can use this vertical farming for that purpose as well. And you can see they are working and take the necessary food from that. Less water is required. You can have deployment in small areas, and similarly, you can have the predictable output as well, that how much we will have from these plants. Similarly, in this type of farming, we can reuse or recycle the same plants. We can collect evaporated water and we can reuse them as well. So that is one of the most important thing to save the water. Here are smart agriculture practices. You can see that they are deploying different solutions to provide water, to observe the plants over here, and then onward to detect the pesticide or attack, as well as to reduce the human resource. So what is smart farming? And if we have a look into the smart farming, there are three important components of smart farming. Number one is that how to gather information or data. Number second is that how to analyze those information and how to take decision based on those information. And then the third one is that where we can store all those data or information that they can be used in future to take certain decision. So the three important component is the Internet of Things plus sensors that can be used to gather data. Cloud services will be used to store those information and will ensure its availability to the masses as well. And the third one is the AI tool that can be used for further analysis of those data. And where they will be helpful, they will be helpful to track the plants, to track the disease, and to track the progress of health of those plants. And then onward, you can also look into the monitoring system. And monitoring system is mostly to check for a take, either physical, through pesticide, or even you can say the monitoring of the material that is required, like it can be water, it can be wind, it can be fertilizer, or it can be any kind of medicine which is required for that particular plant. And then the automating analyzing process, which can help us to provide all the necessary actions that is. Now you can see here, this is a smart field, and here they are using the drone, they are using tractors, they have specifically partitions the lands as per requirement or as per the capacity of drones. Because the ground preparation by itself is very important, that how much area the drone can cover, so you can accurately and precisely take the images and videos from that region. And here is the smart technology that can be used, and you can see here the IoT sensor that start from soil moisture sensors, then machine and the other equipment where it can be used and where we can guide them to go over there, the water management, and then the monitoring through drones item. So the IoT actually make a kind of ecosystem for monitoring and then to take actions as per requirement. Now here is the positive side of IoT. You can see the benefits that IoT can provide. The first thing is the data. If you don't have any data, you wouldn't be able to take any decision. And then onward, after further analysis, you can see the production risk. Either the production will be lower, and what will be the reason of that? And what action we can take in the start to increase the production. Then the cost management and waste reduction as well. As we had discussed so far, we have some discussion on the quality of food as well. So this will actually help us that how we can manage costs. By producing high quality food, we can earn more, and with low quality food, you can go through to the wastage of those food as well. Then the processes of the automation that started from day one, and then all the coordination with the machines, with the sensors, that they are working properly. Then enhance the product quality and the volume, the numbers, plus the quality, and further analysis. Now, even sometimes, and before it's ripened down, there are a few experts without IoT. I'm talking about my country. They take the complete whole farm of mangoes. For example, I take on this one. And from the initial production, they just know that what quality of food it will be. And after that, they starting extra caring of those crops once they purchase it in early, you can say in early childhood of those plants, they actually purchase it. Then the environmental factor, unfortunately, it's not in our control, but still at least we do the necessary preparation accordingly. And you can see here that it shows the sun, the water, and the temperature over here are the moisture. It's though not in our control, but still we can prepare ourselves that it should cause limited or minimum damage to our crops. Here are the requirement of smart farming. You can say in terms of hardware, we should have the sensors, we should have the processing capabilities as well. It's not only the processing capability on IoT, but we should have a huge server where we can gather all these data. Then the maintenance of those hardware. For example, there is an animal going through the field and they damage the IoT device, so you should take care of that as well. The mobility of that items, machinery, and then onward information, the infrastructure that you should deploy, that where the tractor will go, where the human being will go. So you should not deploy these devices in such region where they can be damaged. Then the connectivity, and it should be at a level that they must connect with the network. And then the data collection and the data security. There is also in future, though these networks are not very common, that's why we are not talking about the security, but in future it will be a threat as well. Sometimes I give talk on cybersecurity as well, and there I say that earlier it was a kind of war which was through stones. Later on we have swords. So the war weapon was sword. Then we have the bullets, the rifles, and that was used as an equipment for war. Then we have atomic bombs, atomic wars. And then in COVID-19, we have seen the bio war, that the bio viruses are bacterial, are infection, things are used to attack any nation, even all the human beings, specifically in COVID-19. But the next one will be the cyber war, because we are moving toward automation. And even the Elon Musk got the permission to implant chip in human brain. So just imagine once the brain is connected with the chip, it accepts all the instructions from there. So if anyone hack that chip or pass some wrong instruction to the chip, then what will happen? So the future is about the cyber war. Anyone now the focus, if we have a category like post-COVID and pre-COVID, there is now means a war before technological advancement and artificial intelligence, and war after technological advancement and artificial intelligence. So the new war with AI and technological development is not about destruction. Remember, it's about hacking all those equipments and bring them on your side. So the new war through robots will not be to destroy robots, just to hack them and to bring them on your side. Here is the smart farming, as we discussed earlier. Here is a research paper developing the smart farming index across countries. So this has already been started, that they will categorize. Like we have checked a grading in artificial intelligence. We have grading the countries grading in cybersecurity, and similarly we have seen the grading in our agriculture. Use of smart technologies through that. That how much you are working on that, and it's also part of the United Nations SDGs. That how much your country is working, your infrastructure is equipped accordingly, that you can easily attain that SDG. Here is the countries which we mentioned earlier. And now coming toward the smart agriculture, and you can see here, first thing is that we need to identify the hardware, how we will gather data. And the data gathering is through agriculture sensors. From the bottom, we can deploy the sensor, but from the top side, we will use the drones who will gather data through videos and through images. And after getting the data, we will analyze them. That will have the pre-processing of data, that will have the feature extraction of those data, and that will have to use different AI model to further streamline those data items and to prepare them to take certain decision. And the last one is to take measure and report. Once you gather data, then onward you will be able to take the decision. Here are the application of these small tools in smart agriculture. You can see here the sensors can be used for leaves, for stem, its growth, the temperature sensor for humidity, and for fruit size. While here in services, we can use in pesticide, irrigation, fungicide, herbicide, fertilization, soil preparation, and the yield condition. While on application side, we use for water and nutrition monitoring, the diseases and bug monitoring, the soil monitoring, as I told earlier, that either this type of soil is good to plant or to produce any specific kind of crop or not. Then the crop health monitoring, and then the machinery and its connectivity with the devices, and then the overall environment of your field. So these are the projects I showed you earlier. And then here are the hardware details. And if we have a look, this is called the Arduino board. And from here, we will provide the power supply. This is the processor. And then onward, these are the points where we actually connect our sensor nodes. So on this page, you can see here that we have these 2 points for the power connectivity. These 2 points. The black one that you can provide directly power through this, and even the power range has been given that is 7 to 12 volts. And this is to provide power through USB port to connect it with your computer. We normally use through USB port to further configure them. This is the reset button. And I also have one over here, the board, and we will one by one do it accordingly. Then we have the transmission and reception LEDs, the lights that will blink once there is some reception of data and there is some transmission of data. Then we have few digital pins on this side, and you can see we have 13 pins over here. And then the LED pin is over here in front of pin 13. Out of these pins, we have the power 5 and 3 volts, and we have the ground pins as well. Then we have over here, you can see the power and the ground pins. Use these pins to provide 5-volt power and ground to your circuit. And then onward, this is the power LED, which will show you the power is coming to this tool. And then onward, this is the microcontroller, which actually control all the functions that is happening on this board. And here are the hardware, and specifically related to agriculture, I actually make this presentation. So we have the temperature sensors, like here you can see waterproof temperature sensors, and we have 3 connections. One is the power, the data, and the ground. And then onward, we have DHT11 temperature for humidity. And this blue one is DHT11. And the other one, the white one, is DHT22 temperature and humidity sensor. So it will be actually used to gather information related to humidity and temperature. Then we also have the LCD crystals. We can also look at the outcomes on our monitors. But for example, if you don't have the laptop and you provide power from external sources, then you can use the LCD to get the information. There are certain resistors which actually used to control the electric current through these circuits. And then we have the diode, which actually ensure electricity should flow in one direction. So just to avoid any kind of damage of your circuitry, we use it in specialized cases. Here are the wires that we use for connectivity purposes, and these wires are called jumper wires. You can connect 1 or 2 sensors with the Arduino board directly, but when you want to connect multiple sensors node, then we use the breadboard over here. Then use these wires to connect them with each other. And here we have the light emitting diodes. This is the positive side from which we can, the longer side is positive. This is called anode, and the negative side, which is called cathode, is connected with the ground. So we use these lightning to get some information that yes, the data is passing, the processing is happening. Otherwise, if there's nothing like that, then it will. You can see here the anode connect to power, positive side, and the cathode is the ground side. So here is the Arduino. Welcome to this one. Once you receive the kit, you will have a wooden plate like this designed for that. And this is wooden is just for the protection purposes, so you may not be damaged by it. So first you need to take this wood sheet and separate the pieces which has been given over here, and then secure your Arduino by pressing these screws that it should be planted on the wood plate. And here you can see the function that you can feed the pin over here so that it should be up from the earth or the table level as well. So these are used as a kind of, you can say, the feet. The feet are the stain for this wooden shape, and then onward you deploy the board on it. And here, the first thing after doing this, you need to install the Arduino IDE. So you will start to download the Arduino IDE through which you will write your program. And the IoT will allow you to communicate with the Arduino board. And here is the link. I put it here that you can easily download these for yourself. Then click on the Start menu and open the control panel and navigate to System and Security. And then onward, you can further open the Device Manager. Now, remember, there is a difference for Windows and for MacBook, or even for Linux. So download the right IDE as well as download the right functions, because the structures, you can say the architecture of MacBook and the operating system is very different from the Windows and Linux. Here is the first program. You can see here, here's first program that we run on these Arduino board, and I will perform this practically as well. Here are some examples, and you can learn from this as well. So the basic example here is by blinking the light on this, that you just check that the light is blinking, and it means it can cover or it can work properly. So here is the blink functions that you can use. And similarly, you can check your boards. There are different types of Arduino boards that you can check from here, and which one. Normally we use Arduino Uno, so therefore you select this button. So selection of board and then starting the first sketch. Now the first important thing is that how we can upload our program to the Arduino board. And here you can see that we can upload through this button. This is the button. By clicking this, normally in programming function, we use such button for compilation of program. While here this button is used to put your code on the hardware. And in this situation, we have the Arduino Uno. So to upload the blink sketch on the board, and then the light will start toggling. You will see the progress of upload at the bottom. At the bottom, you will see that how much program has been uploaded, and then you will see that the power button, or you can see the light will start blinking once the program is uploaded on the board. So here you can see LED L next to it will start blinking. So if it's successfully uploaded on the board, then it will start blinking. So here is the bare board, as I mentioned earlier, and here is its structure. You can see that these power buttons, the positive, here we will connect the positive side, and here we will connect the negative side. So this is the power lines. These two lines are the power lines, and these lines are connected horizontally here we will connect our devices. So for example, if we want to give power to any or multiple equipment, for example, I want to give power, so I will bring this cable uh, to insert one side here and the other side here. So I have 4 points now to provide power. So it simply multiply the breadboard to provide power. And similarly, if I provide ground on this one, then I will be able to provide ground to 4 more devices. So 4 more devices may have the ground and power. You can see from here, this is the power and the negative side. And here it is. Yeah. Fixed from the same and show. Yes, 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 yes. Yes, yes. Exactly, yeah, that's fine. Хотелось бы вас попросить, чтобы вы сфокусировались и точно запомнили, что как выглядит, потому что в дальнейшем мы будем практическую часть, чтобы вы смогли самостоятельно производить и так далее. Yes. We go closer. Thank you. So you can see here, we have the positive, we have the negative, right? And this is the internal connect. So if I want to take positive, then I will connect it here. So all these lines in horizontally, I can provide power from here. It's simply like we have the extension of our electricity. We plug in, and there are 4 more points where we can insert to get the power. And similarly, from the other side, we will get the negative. And let me show you one more thing. I have made this circuit. Can you gather together here? You come close. Yeah. Can come. So look, this is the power supply, right? And I connect it here with this one. This. Yeah, this is power, and I will connect it with the laptop, right? This is the sensor for humidity and temperature, right? This is the sensor for moisture, right? And now you can see that we have 3 type of cables here. One is for power, one is for ground, and one is for data. So you can see here that the power cable is this one, the red one. Always use red for the power, right? And black or blue for the ground. So it will not cause any disaster or damage, right? Red is international standard to use for power. So now if you have a look to come for power, I put it here. I put this red line here, right? And now from here you can see that we are getting power of 5 volt to connect it here. So this red is getting power from the 5 volt of this. So 5 volt is mentioned here. Let me move a bit back. Yeah. Okay. Okay.
Вы можете показать, таким глазам будет объяснить?
Yes. Yeah. Thank you. Look at this. This is the power. Yeah. This is the 5 volt power. And these are the two grounds. Two ground. So I take power from this, put it in the positive side. And then I take the ground from this and put it on the negative side. Right? And then now I connect my sensors with these nodes. And here you can see now they're showing them. It will be helpful for them. Yeah.
But this is a multiple. It just is not
Okay. Okay. We can do like that. So here we have actually connected our devices, and this is the small project. You can see here we have a resistor, and we just blink the light. We just blink the light over here, and this is the circuit diagram. You can see here the circuit diagram is given here. We haven't attached any kind of sensors yet. We just attach the LED here and then onward provide them the power button. Here is the first interactive session. Now we are a bit extending. So first we connect this LED, it turned on, but we have no control unless and until to press the reset button of the board. Now we put this button as well. So now we operate this light LED from this button on and off, right? And then after this, you can see here, now moving toward this, that was the basic one. You just check the LED. Now moving toward the sensor side, and you can see here that we have Arduino ground, the power, the 5 volt power. Then we have the pin number 2 that is used for communication. So for analog communication, we used a 0, 1, 2, 3, and 5 pins, and they are given here on this side with the power and ground. And on this side are our digital pins, right? So we actually use the pin number 2 to collect data. We use the VCC for power, and then we use the ground, and then onward we connect the DHT11. I told you there are two types of sensors, so you need to look into that either you are using 22 or you are using 11. And from there, you can see the connection with the two, the first one. Then this one is connection with the ground, GND. GND stands for ground. And this one is connection, the red one. You look at this. The red one, the red wire is used to connect with the power. So it will give power, and then onward it will sense the environment to gather data. One more important thing is that you look at the space that and how much space or how much is the excess of this sensor that it can successfully gather data, right? And then after that, you can deploy the next sensor, and so on. So you can show, and then I will take them to the next level.
Датчик температуры, температура влажность. Комнату подразделение заняла теплица почем, из-за которого мы можем считать температуру, поставить это датчик температуры 10-11. Это датчик температуры и влажности. Мы можем подключить легко к Arduino и получить данные. Да, датчик только для определения влажности.
Температуры и влажности. Легко подключается и может забирать данные. Подключается, вот только Муаззам показал эту схему.
And here you can see, before using this sensor, we need to install this library. We need to install the library for DHT sensor. And for that purpose, you can see that we have to go to manage libraries. We go to tools and to manage library. After clicking on manage library, we will have this screen. And in this screen, we can search here for DHT sensor library. You can have different types of sensors. So you can search the library for any specific sensor here. But in this situation, we have the sensor DHT11. So therefore, we will search the library here. So once the library come here, then we will means click on install. So we install the library on our board. And here is the first example, and you can see here the blink example was. Now I am going to the example again, and there is the DHT sensor library. So I click on the DHT sensor library and I perform the DHT tester. So now I am testing this sensors, that how it is getting data for me and how it is collecting data. And here you can see the DHT11 code, which is available after clicking on the tester. And you can see here, this is already given in the example, and we need to select that which sensor we have. So they have given DHT11 and 22, but you just need to comment, to put these two slash lines, you can comment an instruction and uncomment the 11. If you have 22, so you will uncomment this instruction and will comment the other instruction. So the other things will go accordingly. And similarly here you have to check the DHT pin from where it will receive data information. And here is the COM9 port through which you can compile and you can get the final result. You have to check the port that either it is connected with the right port of your computer system, and after that you will get this information. So now you can see that it is receiving data about humidity, 73% time, the temperature, 27, the heat index is also given over here. So you can gather this data, and any fluctuation or any disturbance will cause the LED light blink. And it also means generate an alarm. For example, if the temperature is increasing very high. So it means that you should provide water that it can decrease the temperature level on the ground as well. And here is the display. You can see here, the display board is also given here. And especially if you don't have the laptop, then you need this display. So display is connected as well through 4 wires. And you can see here that here is the display machine with us. And it is connected with the small board here. Otherwise, it has 16 cable. To make it smarter, we just use 4. We can show that. And for what purpose these 4 cables will be used, you can see here that one is used SDA with A4. This is analog pin 4, analog pin 5, and then onward data is on 2, digital port number 2, and then we have the power 5 volt through VCC and the ground. So let me show it here from the board as well. We will connect it here, LCC, and then onward the power over here, and then we have the last 2 connectivity over here for getting information on that.
На
So
самом деле этот экран подключается по 16 пинам. Но это очень неудобно, потому что очень много проводов и так далее. Для этого упростили схему, добавили I2C модуль, который подключается только по 4 проводам. Она сама декомпилирует и меняет. Для подключения есть минус, плюс и 2 кабеля сигнальных.
В том случае, если у вас нет ноутбука.
Да, можно будет выводить информацию дополнительно или как-то сохранить, и потом просматривать.
And now here is the sensor. We also have this sensor as well for temperature and this purpose, and as well as that one. You can show both. We can have different types of sensors. So you look at the type of sensor that has been used for moisture level. So here is the moisture sensor, and there are two pins for the connection purposes. And you can see here that the moisture pin is actually connected to this board. So this board actually provides us information. You can show this board as well. And onward, this board is connected to analog, A0, the digital one, and then the ground and the power, the VCC. Yeah, sometimes it's also written here that which pin will be connected with which connection over there on the board. So, but in many is it's not very expensive. So in cheap items, and sometimes they also miss to mention here. So it's better. I will give you a book as well for this purpose, which will help you to do this connection stepwise. But normally, as per standard, these two are used for the ground and power, and the other one is used for the data transmission. So here you can see the circuitry that we have done so far. This is the power, this is the ground, and this is for the analog signal. And then onward it is connected with. So you will fix it. Yeah, please.
Это датчик влажности почвы. То есть мы можем воткнуть это в почву и считывать, какая влажность. Для его работы нам нужен отдельный модуль, который тоже будет для нас информацию декодировать. Она подключается легко, то есть, как доктор Мазон показал, плюс-минус, и сигнальный провод идет на аналоговую пин или же цифровую, как мы хотим получить в процентах, или хотим получать либо влажно, либо нет.
Это мы можем выйти на поле и сразу определить.
Да, можно в отсылке, но получается все. Да. Ну, это как вот эти тестеры же есть, как также работают. Да.
So from here you can get the sensing capabilities and the moisture level. So here is the program for the moisture level. This is very basic level of program. The moisture level will come on signal A0, and then onward it will print the moisture level on the screen. So what is the moisture level? You run the program, and then onward you click on the serial monitor to get the actual level. And this is the, as mentioned earlier, that you can comment and uncomment these programs. And these are the few examples of this program, related humidity, related temperature, and related sensor, which is the most important things considered in agriculture. So thank you so much. And now if you want, I will show you to use this.
Помочь.
With
У нас есть ли вопросы к доктору Малазану, доктору Султану по поводу вот этих вот техсенсоров? У меня вообще-то есть вопрос. Оно очень выглядит очень-очень нежно. Как оно будет работать в поле вообще, в грязи, да? Just a question.
yes, yes.
This looks like very like simple. Like simple.
Yeah, yeah.
And when you work in the field, it's usually work with dirt, with soil, etc.
Yeah.
And also with the water.
Yes.
And if you will put this one to the soil, it will be shiny with the water, etc. It
No.
will be dirty, everything.
So we
It will
will,
not be damaged because it's also the metal.
we should not flood water too fast that it should take everything. In modern agriculture, there is water sprinkler. You just have a small amount of water everywhere. It's not to flow like a river or a stream, to take all the hard way. So the modern agriculture is through sprinkling with the help of machine.